Hi everyone. For this question, given that two vectors A and B, where vector A is equals to 2, 1, Q, vector B is equals to Q, negative 2, and 2Q. Then for the first question, determine the value of Q such that A and B has the same magnitude. It means that the magnitude of A will be equals to the magnitude of B. So, in finding a vector magnitude, the formula will be x squared plus y squared and z squared. Therefore, for this question, for vector A, it will be 2 squared plus 1 squared plus q squared. For vector B, it will be q squared plus negative 2 squared and 2q squared. Simplify this square root equation. Where we can notice here, we can square both sides to get off the square root. So here we have 5 plus q squared. And then here we have q squared plus 4 plus 4q squared. Simplify the q squared here. Here we have 5q squared. Move to the left hand side, negative 4q squared. And then 5 move to the right hand side, it will be negative 1. So q squared will be 1 over 4. For solving the q will be positive negative square root of 1 over 4. Therefore, q we have two answers, which is positive 1 over 2 or negative 1 over 2. Then for the question B, it said if q equals to 4, therefore vector A will become 2, 1, 4. Vector B will become 4, negative 2, and 8. The question will be, find the angle between the vector B and this vector. So to find the angle between two vectors, the formula needed here will be cos theta equals to A dot B over magnitude A, magnitude B. So the vector needed here is vector B and 1 times A minus 1 over 2B. So firstly, we find out what is the vector of 1 over 2 times A minus 1 over 2B. Vector A, 2, 1, 4 minus 1 over 2 times vector B. Multiply 1 over 2 into the vector B here. Then we simplify. 2 minus 2, 0 times 1 over 2 is 0. Here 1 plus 1 is 2, 2 over 2 is 1. And 4 minus 4 is 0. So for this vector, we already identified it is 1j. And then the magnitude. The magnitude of 1 over 2 vector A minus 1 over 2 vector B. It will be square root of x squared, y squared, and z squared. So equivalent to 1 squared, which is 1. Then we continue finding another vector that we want to find here is vector B. So we find out the magnitude of vector B. 4 squared, negative 2 squared, and 8 squared. give us square root 84. Then lastly, we find out the angle between these two vectors using the cos formula. So cos theta equals to the vector B dot with another vector that we found here, which is 0, 1, 0 over their magnitude. Then we shift our cos to the right hand side and simplify the dot product here. 0 times 4, 0. This one we get negative 2. And then 0 times negative 8 is 0. So when we simplify, we get 102.6. Then we continue for the part C. They say ask to find value of Q with A cross B is 8, negative 4, negative 6. So to finding A cross B, we need determinant of 3 by 3. For the first row is ijk. Then for the second row, where that is a vector A, which is 2, 1, negative Q, then vector B, Q, negative 2, 2, Q. So simplify this determinant 3 by 3, it will be minus of I, minus of J, and then minus of K. Minor will be obtained by eliminate the first row and first column, so remaining element is 1Q, negative 2, 2Q, then Q and 2Q directly go to the second minor, 1, negative 2 to the third minor. Then vertically here we can see this is 2Q, 2Q. So simplify this minor, it will be AD minus BC. So 2Q minus negative 2Q, it will be plus. Then we can compare our vector. Given vector for x is 4q, vector for y is negative 4, vector for z is negative 6. Since we only want to find one unknown, we just take one information. Let's compare for the x, where 4q is equals to 8. So therefore, q will be equals to 2. Then we proceed for the part 2. For the part 2, they're asking for determine the Cartesian equation of the plane. So we want Cartesian form for plane equation. Pass through the point 1, 0, 2 and perpendicular to A. When we want plane equation, the formula will be R dot N equals to A dot N. So for this plane, they tell us say that this plane is passed through the point 1, 0, 2. So means that the point 1, 0, 2 is inside this plane and it is perpendicular to vector A. So it is perpendicular to vector A. Therefore, in finding equation of the plane, we need normal and we need a position vector from the point. So for the normal, it will be the vector perpendicular to the plane, which is our vector A, where our vector A is equals to 2, 1, Q, where Q we already found it, which is 2, 1, 2. Meanwhile, a position vector inside the plane. So this is the position or the point that the plane passed through, which is 1, 0, 2. So to find the equation of the plane, we substitute vector r as x, y, z, normal as 2, 1, 2 equals to position vector of the point 1, 0, 2 dot with normal 2, 1, 2. So simplify this to the Cartesian form where x times 2x, then y times 1, then z times 2. Here we have 2 plus 2 times 2, 4. So finally we have 2x plus y plus 2z, which is equal to 6. And this is the simplest form for our equation.